Now here we study what is called as logarithmic differentiation. That is, to differentiate a function of the type f of x whole raised to g of x, where f and g are some functions of x, or to differentiate a function which involves a complicated product or divisions. Then what do we do is, rather than directly trying to evaluate the derivative, we first take the log of both sides and then differentiate as usual. Okay, so the only important step here is to take the log first and then differentiate. Alright, now let's see a couple of examples to illustrate this. Differentiate y given by this particular expression as shown on the right hand side. Now we see that basically on high level this function y is nothing but the division of two functions, that is u and v. So we could very well use the division rule, but you see that u and v individually are nothing but the product of two functions themselves. So therefore using the division rule will prove to be a very tedious process. So therefore first we take the log of both sides and then differentiate. So therefore if you take the log of y, then that is equal to log of 2x plus 1 whole squared into 3x minus 1 divided by x plus 2 into x plus 4 whole raised to 2 by 3. So that is further equal to, now we know that log of the division is nothing but the subtraction of logs. So therefore that is equal to log of 2x plus 1 squared into 3x minus 1 minus log of x plus 2 into x plus 4 raised to 2 by 3. And splitting that further, we see that log is the product of two functions. So therefore we know that as a log of product is addition of logs. So here we have log of 2x plus 1 whole squared plus log of 3x minus 1 minus, now in the second term also we will split the log as addition of two logs, but since we have the minus sign outside, we will have both of the log terms as negative terms. So that is minus log of x plus 2 minus log of x plus 4 whole raised to 2 by 3. Now we are already familiar with the process till this point. It involves the properties of log. So what we have found so far is just the log of y. Okay, now if you want we can solve that further, that is the index 2 can be brought down as a multiplier. So that is 2 log of 2x plus 1 plus second term as it is, which is log of 3x minus 1 minus third term also as it is, that is log of x plus 2, and minus the last term is 2 by 3 into log of x plus 4. So now therefore we have to now differentiate, because we have taken the log and simplified. Now if you see that we have 4 log terms on the right hand side, so therefore it is very easy to differentiate the individual log terms. So therefore now differentiating we get, on the left hand side derivative of log y is nothing but 1 upon y, but if you remember we have to differentiate with respect to x. So therefore we cannot just stop at 1 upon y, we have to further multiply by derivative of y with respect to x, which is nothing but we have used the chain rule, right? So this is equal to, now on right hand side we have to differentiate first 2 into log of 2x plus 1. So 2 will remain as it is, it's a constant. Then log of 2x plus 1 will be 1 upon 2x plus 1 multiplied by the derivative of 2x plus 1. So here also we use the chain rule, and derivative of 2x plus 1 is nothing but just 2, because that's the derivative of 2x, and derivative of 1 is 0. Correct? Now moving ahead, second term is log of 3x minus 1. So its derivative is 1 upon 3x minus 1 multiplied by derivative of 3x minus 1, which is 3, right? Then moving ahead, minus log of x plus 2, its derivative will be simply 1 upon x plus 2, okay? And then last term is minus 2 by 3 as it is, into log of x plus 4 will be 1 upon x plus 4, right? So therefore finally alright, finally whenever we want to write the derivative, that is dy by dx, that is equal to, the only last step now is we have to bring the y which is on left hand side to the right hand side. So I can write it as y into the entire expression, that is, now here we can write it as 2 into 2 4 upon 2x plus 1 plus 3 upon 3x minus 1 minus 1 upon x plus 2 minus 2 upon 3 into x plus 4, and at the end we replace y with the given function, which gives us the final answer, right? Let's see one more question. Differentiate x raised to x with respect to x. Now this is the type of one function raised to another function, alright, that is x raised to x. So let's start by calling the given function as y. So let y equal to x raised to x. As per the process, we have to first take the log. So that is log of y is nothing but log of x raised to x, which is nothing but x log x, right? So therefore log y is equal to x log x. Now next process is the differentiation. Now we differentiate both sides with respect to x. So therefore derivative of log y is 1 upon y into derivative of y is equal to, now on the left hand side we see that we have a product of two functions, so we use the product rule, that is first function x into derivative of second function, and derivative of log x is 1 upon x plus second function as it is, which is log x, into derivative of first function, that is derivative of x, which is nothing but 1. So therefore we have right hand side as simply 1 plus log x. So dy by dx is nothing but we have to bring y on right hand side, so that is y into 1 plus log x, and lastly we replace y with the given function, that is x raised to x into 1 plus log x. So that is the final answer of the derivative. So this is how we use the logarithmic differentiation.